Hey guys, welcome to JMaths Academy and welcome to Surds class. In today's class, I'll be introducing you to surds. I'll give you examples. I'll state the types of surds we have. I'll give you a hint and finally a summary. Let's get started. Introduction to surd. What does surd mean? When we can't simplify a number to remove a square root, a cube root, or any other root, then it is a surd. Example, if we have the square root of 2, 2 cannot be simplified to remove the root, therefore it is a surd. If we have the square root of 3, is also a surd because 3 here cannot be simplified to remove this root. Root 5 is a surd. Root 7 is a surd, and so on and so forth. But root 4 is not a surd. Why? Because the square root of 4 is 2. That means 4 can be simplified to get 2. The square root of 9 is not a surd. The square root of 16 is not a surd. The square root of 64, the cube root of 27 is not a surd because it can be simplified, and so on and so forth. So that's all for surd. And in addition, around 820 AD, Al-Khwarizmi, the Persian guy who named algorithm, called irrational numbers inaudible, and this later was transformed into Latin, which is called surdus. And surdus means deaf or mute. We got this from mathsisfun.com, so you can go there to get more explanation on the surds. Okay, so as we said before, these are not surds. Root 4, root 9, root 16, root 64, and the third root of 27 are not surds. So all these are not surds, but these are surds. Okay, so we have more examples here. Example 1 says that the square root of 3 can't be simplified further, so it is not a surd. Yeah, what this means is if you are trying to find the exact root of 3, this will give you 1.7320 and so on and so forth. And since it won't give you a whole number, it's giving you a decimal, then it is what? A surd. And let me give you more examples. The square root of 5 will give us 2.2 continue. Since it's not giving us a whole number, since it cannot be simplified down, then it is not a surd. And lastly, the square root of 2 will give us 1.414. Therefore, it is a surd because 2 here cannot be simplified to give you an exact root. 2 cannot be simplified to give you an exact root, except it will give us decimals. That's all for that. The next example here says that the square root of 4 can be simplified further, so it is a surd. Yes. If you're trying to find the square root of 4, you can do that using factorization. Square root of 4 is 2. By factorizing, you have 2 going to 4 in 2 places, so you have 2 here is 1, and 2 multiplied by 2 will give us 4. And in indices, 2 raised to the power of 2 is also 4. So I can substitute 4 for 2 raised to the power of 2, and therefore this will give us 2 raised to the power of 2. And these 2 can cancel out this root to remove the root, and finally we have 2 as our answer. And this implies that this implies that the square root of 4 is not a surd. And let me add more examples for you. If you have the square root of 9. Let's find the factors of 9. 9, 3 into 9 is 3. 3 is 1. So 3 raised to the power of 2 is equal to 9. So I can substitute 3 raised to the power of 2 for 9. 2 can also cancel this root out to give me what? 3, and therefore this is not a sword. Root 9 here is not a sword. So I think that's that for that. With all these examples, I'm sure you know which swords are swords and which roots are not swords. Okay? Which roots are swords and which roots are not swords.